this assessment asks us to provide an arrow pushing mechanism for the reaction of this alkene with both HBr and HCl. The products we have over here already. So to do this reaction, the alkene, the double bond of the alkene is where the electron density is. That's our nucleophile. The hydrogen is our electrophile because the bromine is electronegative. So we can take the arrows from the alkene and attack the hydrogen. And that gives us the carbocation at this position. And we want the carbocation here on the tertiary carbon because it's more stable because the cation is more substituted. And then we end up with a bromide anion, and the anion attacks the carbocation to give us that product. When we do the reaction with HCl, we get basically the exact same thing. The double bond is our electrophile, our nucleophile, sorry. It attacks the hydrogen. And we need the arrow right there. And so we make the cation again, the tertiary carbocation, the more substituted one. The chloride then attacks the carbocation as we did before to give us that product.